Okay, so now we're going to solve a nonlinear system by substitution, and the substitution method involves solving one of the equations for a variable or expression. You can solve both for the same variable and then set them equal to each other, but with these it's usually easier to just solve one and then substitute in to the other equation with the goal of eliminating one of the variables, so get one new equation with one variable only. So we're going to look at the same system that we just graphed, but we're going to use the substitution method to solve. Now, it's usually easiest to look for a coefficient of 1. Well, we have three different choices here. We have this is y, this x, and this y. Well, if I look at this formula, this x is being squared. So it would probably be easier to solve the second equation for y and then substitute that into the first equation for this y. So that's the process I'm going to use, but there are a number of different ways to do that. So again, here is our line. Solve it for y. We're now going to use negative x plus 2 and substitute it back into the first equation for y, and then simplify. So when we do that, we get a quadratic, set it equal to 0. We're going to factor it, set the factors equal to 0, and we get x to be 2 and x to be negative 1. So those are the x coordinates of our solutions. We have to go back and find the y coordinates. So go back to one of your original equations, or I chose to use the line equation, the linear equation, solve for y, and just substitute back in, and you can easily find your y coordinate. So when you substitute in 2, you get 0. When you substitute in negative 1, we get 3. And if you look back at our previous answer, these are the same answers that we got for the graph. So this is the substitution method.